So guys, hello again. Today I'm gonna tell you how to create the Diablo style wall clipping feature. Also, this feature is used for most top-down games such as Path of Exile, Van Helsing, I guess Torchlight, and so on. So, we will do it in Blueprint. I really tried to make simple implementation only through shader, but I've gone into too many corner cases where some bugs occurred, and due to very strict ways how to manipulate the object through the shader, I decided to go with Blueprint. Well, now as you can see from the picture, we have the following scheme. I'll explain everything so you will understand the basic idea behind this pretty simple feature. So, this blue shape is our player. As you notice, we have three, just for the sake of the example, three levels of surrounding walls. On the first one, if our player is behind the wall, we need to make it fully transparent on this level. If we are on the second level, we need to actually make transparent both walls. So, the more walls are covering us, the more walls we need to make transparent. This feature uses multi-line trace, but for the specific object type. So we don't need to handle all static mesh stuff. We don't need to have some collision rules. If the line trace captures the proper object type, it will automatically return the hit result. Also, as you may notice, we have some sort of instancing wall. So when we run through one, we need to make transparent only one part, not the whole. When we proceed to the next part, the previous one should recover from transparent and be opaque, and our current area should be transparent. And this idea is pretty much actually, if you use the approach of megascans, when all materials inherit the master material features, tiling and so on, you can make the material function, then store it inside your master material, and then apply instances on different types of the meshes. Then you need to set the proper object type collision, and this feature will work. What should I tell you more? Just wait a minute, I think. Also, you can make tiling through the material and make the whole wall with some big scale, or you can go with instancing, so you will receive the result you saw from the preview, when one part is actually transparent and all other parts are opaque. Now let's begin with our blueprint logic. So, first of all, let's open project settings. Then we need to scroll down and search for collision and add the object channel. The mine is called wall clip. Default response set to block. So collision works actually in the particular way. To have the proper feedback, you need one type of, actually, I guess if you have two objects, the response to each other should actually be the same. So if I have mesh 1 and mesh 2 and I want to have the proper response, and there, for instance, mesh 1 has wall clip, it says block, default response block is going to all type of channel responses, to dynamic, static, vehicle, physics body, and so on. So this response should be the same on the mesh 2. For instance, if mesh 2 is dynamic, to have the proper feedback to wall clip, it also should set to be blocking the wall clip. Also, as I mentioned, using line trace only for the object channel is cheaper than to line trace through all of world static objects in the scene. Next, what we need to do is to create the scene component. So we will add it to our top-down character or another type of character you want to this feature to work. And here it is. So basically, what you see is the full feature. It's very simple. When you create the scene component, then you should open your character. In my case, it's top-down character. Just add it through the add component ability. So when it's added, we can close our character and continue with developing our feature. Here you can see I have the custom event, which is called check overlap, and on the begin play I use timer, which is set to loop every 0.2 seconds. I don't need to make the timer handle, because when the character is killed, this component will actually destroy everything that it has. So next, I use multi-line trace for object, and here is the function. It's the pure function, just to have my graph clear. So if we open our function, I'm sorry, I don't have the details opened. Yep. So you can see that it's set to pure, so I don't need to have the exact pin. Then it's measuring auto distance, so the length of line trace will be scalable through any distance of camera we will have. It's very good practice to do such stuff. So in output I have the vector for start and end location of my line trace. For the inputs, I don't need any information. So here, what do we have? We use getPlayerCameraManager and use camera location. Then we get owner, because it's the scene component. The owner is our character, so it will return actual location of our character. Then we use distance to actually have the length of our line trace. We also use player camera manager, use get rotation, and from this forward vector multiply it to have the direction. Then we apply, or actually add, the camera location also from our player camera manager. And this goes to the end trace. For the start trace, it's just camera location, so we will be tracing through our position to our character on the proper direction. Next, if we have the hit, we actually go with another loop. Because it's multi-line trace, it will receive, I'm sorry guys, I'm a little bit tired, it will return the array of hit events. So we need to iterate through them. When we iterate, we break the hit result and store the hit actor as our current wall actor. Next, I have the array of actors, which is called current walls. We check whether our actor contains in this array. If it's not contained, we need to add it and proceed. We add it, then we use for each loop to iterate through our array, and then we apply wall clip function. So it means that we are standing behind the wall or the walls. It can be rooftop and side wall. So we need to apply our transparency function to both of them. Wall clip is a function also which has two inputs, actor and boolean, wall and clip. We check whether wall that we produce here through our array actually, if it has valid static mesh component. If it's so, this is the tricky part. We don't need to create dynamic material instance. We just need to get the component by class and set this pretty node, set scalar parameter value on materials. Here we apply the parameter name of our parameter name that we use in our material. In my case, it's clip, and I'll show you later what it does. It's actually some sort of switch between lerping whether our material should go transparent or opaque. And here we have some sort of conversion node which converts the boolean to float. Basically, it will return 0 or 1. Next, and actually this part goes for the first frame. So imagine that we are standing behind the wall and we don't move anywhere. Then comes the second frame, and our current wall actually is inside our array. If it's so, we need to set the temporary array, which is called previous walls. So if we don't move anywhere, the graph will go on this path. But when we move and our multi-line trace will actually find new walls that are not in our current wall array, it will continue with this sort of logic. So when we apply transparency on our wall, move to our next wall, we need to clear the current array. In our case, it's the previous wall. Oh, I'm sorry, not in that way. So if we, let's go to our scene. As you can see, I have selected 3 walls. If we are standing here, behind the first wall, and are iterating through to the next wall, we need to make this wall, the first one, opaque and this one transparent. If you go to other direction, the logic will work or should work the same way. This wall should be opaque and this one should be transparent. So that's the reason we have to erase. So back to our graph. So when we move, we actually go and iterate through our previous wall array. Here we should make our walls opaque again. And then, if we want to go to another direction, we need to remove our elements from our temporary array, from our current wall array. So these elements won't exist here, and when we go back to our previous wall, this logic will fire and it will work perfectly. So I hope you understand the idea. Please, if you don't, just look one more time on the preview. Maybe you should also try to draw this situation to understand the whole idea. Next, when our graph logic is completed, I here use the custom event which is called reset on trace lost. When we are behind the walls, we need to keep tracking whether we are behind them. And if we don't have any wall tracked, we don't need to clear our array and keep our walls changing their material attributes. So for this I use do once node. Then if there was no interaction with the wall, I iterate through the current wall to make them all opaque, and on the exit I clear both arrays. So when new interaction is done, everything will go on the cycle. Now let me show you the material. Actually, this part can be transformed to the material function, and all you need is to open the material of the element you want to be in the feature and add it there. So here, what do we have? I use world position and mask it on the B channel, and the clip size, it's the scalar parameter. So what this feature, this mechanic does, it's see whether our position, whether all elements that are higher the particular value, if they so, they need to be transparent, and everything that is lower than this particular value should be opaque. And as I said, this clip scalar parameter is some sort of switcher between fully opaque or the mask mode. Make sure that the material where you will use this function, the blend type of it is set to be masked, and I guess that's all that I have here. So that's the whole material. Now let me show you how you should work in your scene to actually have this result. So when you are on your level, you can use any sort of model or static mesh to make your level. Then here you can see I use the instance of my master material applied to all elements that should be in this feature. Actually, I can select all of them like this. Next, you should go to the collision, set preset to custom, collision enabled set to query only, you don't need any physics collision, and object type set to our custom object channel. In my case, it's wall clip. By default, you'll see that everything is set to block. You can make all ignore it and just to block our pawn. So it won't get through our wall, it will be blocked. And guys, this the whole setup. So please leave your feedback, subscribe if you like my videos. I'm sorry guys for the speed of my words spoken and my thoughts also reeled. I'm so much tired, but nevertheless, thank you all for your support. So you help my channel to grow. Also, well, I think here I should stop. See you soon with the landscape auto material.